Hello. Okay. Thanks very much. So we will do talks, like kind of like up to 20 minutes. If you can do it in a bit less, it will be better. And then I will be very keen on showing the 5 minutes. And the talks will be taken at the end. So that's why I want, hello. That's why I want to make sure that we have time for some questions that will be at the end. So we will start with Leandro Lombardi, who holds a PhD in mathematics and has worked in topology and algebra. Currently, he's the director of artificial intelligence and Quantit, that is an Argentinian company, where he drives artificial intelligence strategies and oversees technical execution of the company's project. Thanks very much, Leandro.
Okay, so thank you very much for the invitation. It's a pleasure to be here, an honor for me to present these initiatives that we have with Abuelas. Okay, so briefly, what is Quantit? We are a software consultancy firm with focus in AI. Was founded in about 2 years ago, and we're based in Buenos Aires. We have some tight connections with academia and the university, and I think that's one of our differentials. And we've been working in the field for more than 10 years. I had some self-presentation slides just in case, but I will just go through it. Briefly, I just wanted to mention my time on the Sadowski Foundation, where we worked together with Edgar, and that's where the seed of this project was planted a long time ago. Okay, so the focus of this talk will be essentially tell you about Abuelas de Plaza de Mayo, in case you know how they work or what's the mission they have. And then I will briefly speak about what AI can do for these kind of processes. And I understand that that should be pretty obvious for the audience, but anyway. So first of all, what was the situation in Argentina in between 76 and 83? It was one of the most brutal repressive military dictatorships, not the only one in the region. And as you may know, also Chile, Uruguay, I just listed there the countries that had limits with Argentina, but they're not the only ones having dictatorship at the time. That was something that happened not by chance. If you are not aware of that, please search Plan Condor and then weigh down on the fact that we're having this talk in English. Also, it was not the first time we had a dictatorship in Argentina. It was just recently had happened another dictatorship, and we had 5 other coups previous to this one. So what's specifically about this dictatorship? These guys, they kind of doubled down on the repression. And essentially they decided, and the quote is from Videla, who was the first president of this dictatorship, if we want to call him like that. And it says, the disappeared person has no entity. It's a very famous quote. It's not dead, nor alive, it has just disappeared. So the idea behind that is that no body, no crime. So that what happened in the previous dictatorship, that it was the bodies were proof of their crimes. So just make them disappear. So what happened when you capture someone that is a woman and is pregnant? That posed them with a question. Well, they decided, and also because of the previous dictatorship, that killing, assassinating pregnant women was too much for them. They also had this idea that these young women and also men also at the time were raised in a wrong way. So if the children went back to these original families, they will be raising also as new subversive persons. And also they, as anything that they gather from their homes that they rush into, also children and with the unborn children were like war trophies for them, so why not? And also, waiting around this time was this idea of complete impunity. So they can do whatever they want, so why not? So the conclusion they came out was, okay, those children cannot be returned to their original families, shall we just keep it for ourselves or our family members or our friends? Okay, so that's the like brutal thing that happened that raised that gave birth to this mission. So what is Madres and Abuelas? So by 77, just a year after the military weighed in, some mothers gathered around Plaza de Mayo, which is the main square of Buenos Aires, where the governance has its place. And they were start claiming for the children, and they found out that some of them, the women were pregnant, so they started also, like the one that were looking for their maybe born at the time, grandchildren, they like gathered together. And it's very interesting for me that there were the women there because their husbands has to work, so they had no time for this. And most of these ladies at the time, they were like maybe like my grandmother. They were not even know how to reach the city center by themselves. They never had like a bus ride to the center. So by 1980, the first two children were founded, and one thing that happened by '84 was this researcher named King. I like this photo. Is King is a geneticist from the U.S. showing Navajas and Carlotto, two abuelas, the way that you can figure out if someone is your grandchildren via a DNA test, and that's something that abuelas, these of ladies that they were traveling aboard, playing fool, like, oh, this is the first time. They went out and meet with other organisms abroad, and they were asking for help, and they found help with this researcher. Okay, so this posted like a workflow for them. The workflow is mostly, okay, so they start looking for their own grandchildren, so they have these searches, open searches for them, but also some people reach out to them with some testimonies, like saying, okay, I think that I saw some boy or girl appearing out of the sudden, and I think maybe it's not the biological son of the family they have, and stuff like that. So from all that, they gather evidence, mostly in forms of documents, of testimonies of people that reach out to them, and for some reason they didn't go to the justice, they reach out to them. So they gather evidence that somehow weighs down into, okay, we believe this person is not what they think it is. They submit that to justice, or maybe it's a voluntary reach out from that person, and eventually that leads to a DNA test against the National Data Bank. Okay? Okay, so I will fast forward 40 years. The story is way too complex. But at the time, we have 139 possibly solved cases and about 250 open searches. 95 of them were born with their mothers captive. They have about 7,000 open cases and 5,000 discarded cases. That means that maybe the person was illegally adopted or another kind of situation that's not regular, but it's not this kind of appropriation. And about 22,000 documents that was on paper up until recently. And they have about 1,000 documents still on paper. So until today, they go through this manually. Until a couple of years ago, it was really, really manually in terms of going through the documents in paper. And at the time, they are doing some part of this in a computer, but with very low-tech tools. Okay, so what can we do? It's very straightforward, I believe, for this kind of audience, but one thing that we can do is figure out some kind of entities or people names, that kind of stuff in the documents. Some presence of some kind of institutions lead to like a red flag for possibility of being an appropriation. Law enforcement, military, some midwife, obstetricians, judges, people that appear in the expedient at some point might lead to nice, like a lead that could lead to that kind of solve the case. Because they have previously participated in another case that was solved, right? Then some kind of addresses. For instance, one famous son that was restituted was Carlotto's grandchildren, and he was they were saying that he was born in the home of the appropriator. So if you know that address, you can figure this out. And also, well, the place of birth, mostly were saying they were born in in a house and not in a hospital, or in a hospital that is a military hospital. So that was kind of, and all this happens in a sea of other kind of different appropriation crimes. Okay, so another thing that we can do is add with some more efficient search tools. So make sense of these testimonies with retrieval tools, search for testimonies in a non-so textual form, like verbatim quotes of what is saying in the text, but finding something like a fuzzy match on the text. Also, like making, so I think we will have a talk later about how you can make sense out of these documents in a graph. And also we can leverage LLMs to say, okay, do you think these two testimonies belong to the same case or not, with some kind of previous prompting, like a RAG kind of approach. Another complementary approach is also going through the cases and say, okay, they believe most of the searches are still open, have some kind of information already in the archives that they have. So going through the documents and ranking them up and say, okay, we believe this case might be close to be solved, help them prioritize, or like going through them with similarity might be another thing that can help. Also, as I mentioned, there are some documents still on paper, so digitalizing them makes sense. We will have a talk next on that. Okay, so at the end, we can also help with making some of these steps a little bit more efficient or less bureaucratic, like writing summaries or writing a report, something that you can submit. Also, eventually, you can go through the process of investigation and have an agent eventually go through a case and find similar documents and start building that case automatically. Okay, so that's pretty much it. I would like to shout out the team. Of course, we said we were doing this non-profit project for abuelas, and we reached out, and no one said no. Everyone would say, hey, yeah, I'm in. So we have a handful of researchers. More hands are welcome. We already talked with some in the audience. We have some people from UBA, from UNSAM, Berkovich, who's from VC company, but also very enthusiastic on this project. We have students that volunteer also. Maybe this project can be part of their thesis, so great. And also Edgar and me from Quantid, also leading and helping this organization. Okay, so thank you very much. I leave you with some kind of like cry for help. If you have any resources, they are welcome. Of course, this is a project that is completely doing by us in a non-profit format. So especially computer resources are welcome. So that's pretty much it. Thank you.
So remember, questions at the end, so you can write it down. Our next speaker is Ayala Rosá, who is a full-time associate professor at the Instituto de Computación, Facultad de Ingeniería en la Universidad de la República, where she is currently the head of the NLP group. Her main research lines are subjectivity analysis, question answering, information extraction, and NLP for education. And the presentation should start. Uh-oh.
¿Tienes USB-C?
I present too fast, I think. I can keep talking about Ayala. She holds a PhD in computer science from from Universidad de la República and University Paris South, West. USB key, someone? Ah, pero acá. Ahí se puso blanco en todas partes. Yes. The group is, the project is called Cruzar, and it's very beautiful.
Si quieren. Yo te improviso lo que quieras. Pero no hace falta, ¿no? ¿Copiaste en el pendrive? Y usemos la otra compu. Es tu compu,
So in the meanwhile, I can tell you that we will have 4 different countries, Uruguay, Argentina, Chile, and Mexico. And as Leandro said, unfortunately, the dictatorships in the 70s, and I mean, during the Cold War, they were, I mean, they had some similar patterns, but also differences. And the idea of this workshop or session is that you will find that there are some similarities, some common pains, for example, OCR, for example, or like the idea of doing graph neural networks or graphs in general, but also some differences between them, or with which type of documents you are working on. Are you working with military documents, or is civil society, or in the case of Leandro, like from abuelas? Okay. So that's very nice of this type of projects, that you have like different countries, and I think that there is a lot of effort in trying to make easier for the next country to start. Because as Leandro showed, there are many countries in the list of dictatorships, and none all of them have the same type of projects or advancement. And now is the time of Uruguay, that they have had like a decade of work on that. And also, I can invite you tomorrow, if you haven't signed, there is the last event. Do you know that tomorrow we go to Seina? Seina is the center behind the Instituto Nacional in Metro Universidad de Chile. And Domingo Meri will present the work from Chile, okay, at 2:30 p.m. There are still places to go. It's a big, big auditorium for 800 people, so we can all fit. Yeah, if you are in KHIPU, you are immediately registered. But if you are from outside and you only sign for Thursday, you can still sign for Friday, and you can tell other people to sign.
Hola. Okay. Sorry for the delay. Hello, I am Ayala. Jocelyn presented me. Thank you to KHIPU and to Lorena and Jocelyn for inviting me to be part of this session. I will be talking a little about the context in Uruguay, something about the dictatorship in Uruguay, and after that I will talk about the task of extracting and enhancing text from scanned archives of the Uruguayan dictatorship. Some context, between 1973 and 1985, a civic military dictatorship ruled in Uruguay, preceded by state terrorism from 1968. Systematic violations of human rights marked this period, including torture, raping, kidnapping. There were thousands of political prisoners. There were also hundreds of Uruguayans disappeared. Most of them remain missing to this day. The attempts to achieve truth and justice in relation to this historical period have been unsuccessful and have faced many obstacles. One of the main obstacles is this law, la Ley de Caducidad de la Pretensión Punitiva del Estado, that was approved in 1986 and says, I will read a fragment. Ha caducado el ejercicio de la pretensión punitiva del Estado respecto de los delitos cometidos hasta el 1 de marzo de 1985 por funcionarios militares y policiales equiparados y asimilados por móviles políticos o en ocasión del cumplimiento de sus funciones y en ocasión de acciones ordenadas por los mandatos que actuaron durante el periodo de facto. This law is vigente now in Uruguay. Despite these obstacles, over the years, access to some datasets has been achieved. One of these datasets is the so-called Archivo Berruti, found during the mandate of the Minister of Nation Defense, Dr. Susana Berruti. ¿Se escucha mal, no? Pensé que era yo que me escuchaba. Thank you. Susana Berruti was the minister since 2005 to 2008. So this happened 20 years after the democracy returned to Uruguay. In this context, we can locate the Proyecto Cruzar, UI. The object of this project is to systematize and organize the information contained in historical documents, maximizing the quantity and quality of knowledge that is obtained from them. Until now, we have worked with the Archivo Berruti. Now we have some new collections of documents, but the task I will talk about today were done with this Berruti archive. We are an interdisciplinary team. We are engineers, social scientists, archivists, journalists, and human rights activists. Particularly in the engineering team, we are more than 30 researchers, students, and volunteers who have worked in the project from the beginning, maybe more than 30, I don't know. We had a lot of students working with us in different theses and projects. I didn't mention anyone because we are a lot. So some characteristics of the Archivo Berruti. It is composed of microfilmed documents. There are around 3 million pages. We process, we call document to single pages because we didn't work in recognizing complete documents. So our unit for processing is a page. So we are losing context when we work, but we don't know which is the first and the last page of a document. These documents were produced from 1965 to 1999. before the beginning of the dictatorship and after the end of the dictatorship. The texts include handwritten text, machine-written text, pictures, portions of newspaper, and other formats. The digitized images are binary. That means they are in black and white with no shades. So this is a challenge to all the image processing tasks and also to get the text contained in these images. Well, I will talk a little more in detail, but not too detailed, about this stage, this first stage of the processing, that is extracting text from images, what is called optical character recognition, OCR. The idea is we have an image, the first example. We used some tool for OCR, and we obtain a text. In our case, generally the texts are very noisy because the documents are of low quality. So we need a second stage for post-OCR correction to obtain a text with less noise. So I will comment something about how we worked in the OCR stage, but I will talk a little more about the post-OCR correction. For the OCR stage, we tried some OCR tools like Tesseract. It's an existing tool. We can use it. It's an open tool. Then we worked with Calamari. That is an existing tool which we could train with our data. We also work in the development of our own OCR tools with some undergraduate and master students. And last year, we have some students who experimented with multimodal LLMs. All these strategies have the same problem. The text we obtain with them are very noisy. So we need to perform some post-processing, post-correction. And I will present some approaches based in the use of LLMs, large language models, that we done in the last 2 years. We experimented with a pre-trained large language model with prompting. We also did fine-tuning with the same model. And then we used this fine-tuned model with some variants of beam search decoding to get more precise, more accurate texts. I will talk a bit about the ground truth we used for these tasks, because to train the models and to evaluate the results of the different approaches, we need a gold standard or a ground truth to work with. To build this ground truth, we use the Luisa, that is a crowdsourcing platform where users, any user, can introduce transcriptions for images and help to us to construct this gold standard. This is an example of an image. Luisa shows a fragment of the image in the bottom, and there the user has to write what he's reading in the text. This is a a mid-quality text, it's not so easy to know what it says. But in general, we can understand and we can transcribe this. There are other documents that are impossible to transcribe for a human. With the data collected with Luisa, we constructed a ground truth that consists of pairs with a noisy line and a curated line. The noisy line, the examples of the ground truth are lines, not texts. Just one line is one instance of the corpus. The noisy texts are the outputs of the OCR tool, and this is the text we want to correct, to improve. The curated texts are the Luisa transcriptions plus a manual curation made by members of the project, because we detected some problems in the transcriptions of Luisa, but this manual curation was agile and provided a good ground truth to work. The train set has 21,000 pairs, and the test set 2,000 pairs. Ah, no terminé. Qué rápido. No dije nada. Bueno, ¿cuánto tiempo voy? The evaluation, for evaluating the approaches, we did this. We want to reduce the distance between the noisy OCR output and the ground truth. So we calculate this distance, and also we calculate the distance between the corrected OCR output and the ground truth. And we want a method that diminishes this distance. To calculate these distances, we use two metrics: CER, character error rate, and WER, word error rate. Well, when we use prompting with a large language model, in this case we use Llama 213 billion of parameters, and a fine-tuned version of the same model, we couldn't get better results than the OCR, the original OCR could get. So in blue, we can see how much the OCR output is distant from the gold standard. And these are the distances we obtained with the corrected OCR output. These metrics are error metrics, so we want to, they have lower results are better. So we couldn't, these two approaches weren't good. So we tried some variations. And we analyzed the results, and we found that generative approaches are not good for correcting text, and this is obvious because we don't want to generate new text. We want to obtain a text close to the input, but with some characters or some little sequences of characters modified. And we found this kind of problems with the language models. They changed words completely by a synonym, but we didn't want to lose the original text. We wanted to keep the text fieles to the originals. So we tried to combine the language model's capability with a sort of guided search to get the the results or the words that were close to the input. So I will pass to the other method. Here, one of the methods was that that we called constrained beam search. What we are doing here is at each step of the decoding process of the large language model, the model is generating one token at each step. And what we are doing is in each step, we get the k most probable tokens, that is beam search. And we compare this with the original input, and we calculate the distance between what is being generated and the input. So we combined the probabilities that the model give to each word, to each token, with this distance. So we can get, as a result, a combination of what the models think is the most probable token and what is a sequence close to the input. That is our goal, is to obtain a sequence close to the input, corrected, but close to the input. And with this approach, I didn't talk about this one. It's parecido, un poco distinto, pero parecido. With this approach, we could have better results, or we could improve the OCR output and to get lower CER and WER. We could get these sequences are better when we compare at character level, and also when we compare at word level. Well, this was a good approach. We are happy with this approach. It's an interesting approach, but the amount of improvement is not so high. So we will continue to do more experiments. Fortunately, we have students working with us in other tasks related to the Proyecto Cruzar, but all of them, when they see the documents, they want to go back and try new methods to improve the OCR, because it's not easy to work with these noisy texts. So we will continue experimenting with this. One clear line to investigate is to use multimodal large language models and to combine them with a post-OCR correction approach, like the one I explained before. And we are also starting to work in training Tesseract with our gold standard. We tried to do this some years ago when our gold standard was too small, and now we have a data set, a bigger data set, and we think that can work better. Thank you very much. Sorry for my English, it's awful.
Thank you, Ayala. So now is the turn of Víctor Mireles. Víctor Mireles is a professor at the Center for Interdisciplinary Research at UNAM, la Universidad Nacional Autónoma de México, where he develops applications of artificial intelligence into social sciences. His main area of interest is the epistemic and ontological biases present in text corpora, their quantification, and possible remediation. His research combines neural networks, NLP-based, with knowledge graphs. Thanks, Victor.
Oh, great. Hi, everyone. Thanks. So thanks also to the previous two speakers because they've saved me a lot of time. So I'm going to skip a couple of slides, which is, I think, great to see this convergence of approaches. And this only shows that we should have had this workshop maybe 5 years ago. Okay, so it had another title, but now I'll go with this one. So I have some do's but mostly some not to do's when you're trying to build knowledge graphs from texts. Okay, I'm going to talk to you about a project called Angelus, which I will explain a little bit about. This is quite similar to what was previously presented. So in Mexico, there wasn't formally a dictatorship, like military rule in the country ended, I don't know, somewhere in the end of 30s, and it was never as brutal as it was here or Argentina or Uruguay or elsewhere. That doesn't mean that there wasn't similar techniques applied. That doesn't mean that Mexican security forces didn't go to the same schools as the security forces from other countries, and they didn't exchange information. So everything was the same, just with a civilian government and with a little bit of kind of rule of law around it. However, we're in the context of the Cold War, and Mexico being a mostly rural country, especially back then, there was a lot of land conflict, yeah? So people were fighting over lands mostly, or what's relevant here is they were fighting businesses, right? So maybe some of you have heard, I will just give you one example. Some of you have heard about Acapulco. It's a famous beach in Mexico, very famous in that era. It's very beautiful, luxury hotels, etc. So 120,000 people were displaced by force to clear a hill with a very nice sea view to build hotels there. Yeah? And that was in the 60s, right? And instances like that are all over the country. And of course, this elicited some social movements. Some of them became armed. Also in bigger cities, also in Mexico City, of course. And they were then repressed by the same techniques that we've been hearing about. And this led to, this enforced disappearance is just one of them. But one thing that that we have in common also with the previous approaches is that there's a lot of archives and testimonies. And then later in the 90s, early 2000s, there were some judicial investigations kind of that haven't led to anyone being brought to justice, but there's been some work there. And of course, human rights groups and academicians have worked on this. So just to summarize, there's around 1,300 people who were forcefully disappeared in that period. And yeah, we have to find them. But this is also an ongoing problem. Yeah. So in Mexico, there's, it depends who you ask, but the lower boundaries are around 120,000 people whose whereabouts are unknown right now. And it's because these same conflicts are still there. So there's not, the land conflicts are still there because of legal business ventures, yeah, mining companies or whatever extractivist companies come, they need land, and they push people with a variety of legal and illegal means. And this also leads nowadays to social movements, and this intersects in some really wicked way with the so-called war on drugs, because there are, of course, illegal businesses. Yeah, there is, of course, drug problem in Mexico and other illegal businesses. Yeah, and all of this mixes together in something called the war on drugs, which is perpetrated with very similar techniques and sometimes with the same people. Yeah, so there was this, like some of these famous drug dealers that get arrested and sent to the US. Some of them were former military people in charge of counterinsurgency, right? So it's the same people, same techniques, same problem. It's still going on. Okay, so what was Project Angelus? So it was like 6 years ago, a little bit more. there was an attempt, or there is an attempt to try to find these hundreds of thousands people missing, and they came to the Ministry of Science and they said, okay, help us organize these documents. The Ministry of Science was back then called CONACYT. It has changed name since then. And the Ministry of Science put together a bunch of institutes, mostly mathematicians, but also social scientists, to try to do what we just heard, organize the documents and try to go through them as fast as possible, because the people responsible for these atrocities in the 60s, 70s are dying. So it's necessary to be fast about this. Okay. Again, the list of people is too long. I will just put it here. It was a project that lived only a couple of years, and I'm speaking now in past tense because it is at the moment, let's say, hibernating. Okay. And what's the approach? Okay, I will just put a very quick example of this. So there is some, the names here are changed, yeah, but there's some witness account that says that there was a detention occurring in a place called Atoyac, where a guy named Luis was detained by someone that was referred to as Martinez. That's all we know about him. Yeah. That's a witness account. Yeah. And then if you go into the military documents, you realize that this guy, Martinez, is actually commanding officer of some unit, and you find names of people who belong there to that unit. Yes, in this case, some names. Yeah, but that's a completely different document. And then you have, in a completely unrelated case about Diego, you realize that that guy was also detained in Atoyac around the same time, right? So if you're able to put all of these pieces together, you can kind of guess that maybe these guys, Fernando and Pedro, have something to do with Diego. Maybe you should interrogate them. That's the idea. And the idea of Project Angelus was to bring together all of these documents. So some of them are witness accounts. The families have told the stories of what happened to their disappeared people. Some of them are military documents, so that, and they are in the power of the military, which even though it's been decades and changes of government, they're still holding those documents very tightly, right? So that's why this project was nice in the sense that it allowed a little bit of access into these otherwise restricted documents. That's the idea. Okay. And what did we do? Okay, we started by developing an ontology. An ontology is like an organ, you can think of it as a database schema, right? A way to organize the knowledge in one domain. Yeah. But we made it with specific questions in mind. Some of them are here. These questions are aimed at finding answers. Yeah? What happened to the people who are responsible? Who should we ask? Who should we next interrogate? Or where should we search? Yeah? Places. It should be said here that who commissioned this was part of Ministry of the Interior, which is, you can imagine, very high in the government, but it's not a judicial, it's not part of the judiciary, so they cannot prosecute people, so that's a whole nother story. But for now, the idea was to build these kind of files or help build the files to start prosecuting people. Okay, once we have this ontology, we want to organize the documents. This is maybe not so interesting to an AI conference, but once you have a bunch of documents in various states of decay, just scanning them, organizing them, labeling them, it's a challenge by itself. Yeah, you need, of course, you need hands to go there, hopefully with gloves, and scan this stuff. Yeah. But you also need to organize it in a way that can be found later and can be traced, like where did it come from, and so on. Yeah? So in this case, we used a piece of software called Dataverse, which maybe you've seen or your university probably uses to store your thesis. And then we tried to do some preliminary image processing on this, because some of these documents are duplicates, for example, yes? This is very common all over the world when there's an attorney trying to investigate something, they go to some place, get a document, make a photocopy of it, and then some attorney investigating something else makes a photocopy of the same document, so you have a bunch of duplicates. And also you have to scan this by both sides. Most of the reverse sides are empty, but some of them have annotations which are valuable. So you have to do a little bit of very coarse-grained image processing just to find duplicates, discard blank pages. Yeah, then you have to do OCR. As we heard, this is hell. It's very, very difficult. And then the idea was after we have OCR, we're going to do named entity recognition, as was mentioned earlier, to try to find, okay, this document mentions this person, or mentions a person, yeah? And then trying to perform entity linking, yeah? Which means the person called Martinez in one document and Eugenio Martinez in another document, are they the same? How do we know? Yeah? Especially if one of the documents has Martinez with an S and the other one with a Z, and especially if they were OCR'd and you have trees instead of E's or whatever, right? So this is, that's the hard part. And so for this, we developed a UI where you could, the user who were employees of this ministry, they could look at the document on the left side and do annotations on the right side to try to clean up this stuff a little bit. So maybe you cannot see from there, but this is a document, a photocopy, something scanned. These are list of entities which are mentioned there, and these are list of relations among the entities, right? So I think I have it here assumed. So if that document mentions Jose Barron, which is a person, and it mentions the captivity of Jose Barron, yeah, because this document says, yeah, he was in prison back then. And if it also mentions Maria de Jesus, who is another person, then maybe there is a relationship between Maria de Jesus and Jose Barron, and the annotator could choose from a number of predicates and says, yes, it's his mother or whatever. Yeah, okay. And after that, the idea is to have users explore this graph to find answers to these original questions. This is a copy-paste from the previous live. Okay, so let's see. Live demos are always tricky, but everyone cross your fingers. Okay, but I need my notes for this, sorry. Because the graph is a bit too large to get lost in that. Okay, so here we have a person, her name, maybe I can make it a bit larger, is Aida Ramales, okay? And what do we know about this person? So one thing we know, for example, is she has an alias called Nidia. Somewhere they call her like that, okay? We know that she's a member of an called Partido de los Pobres, the Party of the Poor. We also know that she's brother or sister of someone called Florentino, for example. Okay, and about Florentino, we also know that he is member of some organization, which is this Brigada, oops, this, the name, I mean, it's a killing squad or something like this from a guerrilla, Brigada Campesina de Ajusticiamiento, and then you can also see that this organization itself, it's part of Partido de los Pobres, okay? So there you see the graph starts building up a little bit, yeah? Okay, now Aida, we have a lot of history of her, yeah? Well, not a lot, but we know she was tortured, she was captured somewhere, etc. And we know that she was kept in captivity somewhere. Yeah, okay, so I'm going to move this a little bit. Captivity of Aida, we know that it happened in a rendition site called El Ferrocarril. Yeah? And furthermore, we know that there was a witness to this, which is Lorenzo. Okay, and from Lorenzo, if we look at information about him, We know a lot of, we realize he's a member of, maybe it's good that you cannot see it, I don't know. He's a member of several of these armed groups, but he's also a member of the federal police, by the way, yeah? So that's by itself interesting. Okay, and so on. We can keep going like this. You can imagine the graph connects a lot of people, a lot of events, and so on. Okay, so right now we have around 6,000 people in this graph of several different kinds of subclasses of people. We have places and we have events. Events are kind of the most, like the root of this ontology in a sense, right? So it's a graph that has, that was parsed out of 10,000 documents and it has 52,000 edges. Okay, so just quickly. I prepared these slides before seeing the previous presentation, and I would say don't try to correct OCRs with language models, as you said. We run into the exact same, these things just make up stuff that make them less useful, right? So the name Lucio, it's a common name in Spanish, but Lucia is much more common. So if you tell the OCR, tell the LM, in this case, it was Bert, it was some years ago, correct this, it's going to say Lucia, which is a completely different person, right? And it adds some stuff, yeah? So here it's pre-correction, post-correction. Some things it does good, but other things it just messes up in very bad ways. Then try doing named entity recognition and then entity linking on poor quality text. That's also a bad idea, yeah, because so let's say that you have some list of existing entities, and then you get the OCR, you try to correct it, it's never perfect, and then you say, okay, I'm going to do some fuzzy text string matching, right? And there's a lot of literature on that. It's, to be honest, it's a rabbit hole, and nowadays with LLMs, you can skip all of that, yeah? So after the project became in hibernation, I started doing a little bit of experimenting on this. And if you have a list, so this is a list, there are some lists which are structured like Excel sheets. And we have a name here, a list of names. Among them is this Raúl Castañeda Peñalosa, yeah? And on the bottom is the OCR, the Tesseract output, and the LLM finds it perfectly, right? It realizes, yeah, this is the guy you're looking for, even though the spelling is completely wrong. Yeah, so you need some quick, this is a quick recipe. You do first some vectorization, because of course, if you have 6,000 people, you cannot put all 6,000 people plus their context, like where were they born, blah, blah, into the prompt. It's going to take forever. It's going to cost you money if you're paying for it. So you'd like to have some candidates, yeah? So I did it with 50 most likely entities based on very quick vector search of character engrams, like trigrams, just to kind of try to catch these errors, and then it works. It works nice, and what's interesting here is that you need to serialize the entities, or verbalize, I like to call them, yeah? So this Excel sheet that I showed you, you don't just put it to the LLM. I mean, you can do this, but you can just say, okay, this is the list of people, and for each of these persons, I know something, yeah? I know that this Peñalosa guy was born in this year, was detained in this year, belonged to this organization. This already helps the LLM do the entity linking and the entity disambiguation in the case where you have people with similar names, yeah? So doing this serialization is really important, and here's a small paper which is still in the future, but you can, it's not mine at all, yeah, but it's been uploaded a couple of months ago by some Amazon people, where they show some nice strategies on how to verbalize knowledge graphs, or how to verbalize things for entity linking, right? So it's pretty cool. Okay, so if I have one more minute, I'll just say, think of questions, not data, yeah? Because one first impulse is say, yeah, get everything you can out of the documents. You can find names, find events, find everything. It's very hard, especially if you have to do manual annotation. It's hard for the people to do this, And the more refined your classes are, like we had people and we had victims and we had perpetrators and blah, if you refine them a lot, the NER is just going to fail more and more. Yeah? And do several iterations of the ontology. Yeah? So come up with one ontology, try it out, see how it works, refine it. You will end up with a much thinner ontology, which will work much more, much better. And yeah, that's it. Thanks a lot.
Our next speaker is Juan Reuter. Juan is an associate professor at the Department of Computer Sciences at the Institute for Mathematical Engineering and Computing at the Pontificia Universidad Católica de Chile. He also serves as the director of the Institute for Foundational Research on Data. His research focuses on the mathematical foundations of data management, web data, and artificial intelligence. At the Institute, he co-leads an interdisciplinary team studying the socio-political effects on data. He earned his PhD from the University of Edinburgh in 2013.
Thanks, Jocelyn. Okay, so thanks to the past speakers also for motivating what I'm going to do, especially thanks to Victor, because now I don't have to motivate the use of knowledge graphs. I think that your demo was very enlightening. So I just want to say that we're not the only ones that think in terms of knowledge graphs to organize information that will later be consumed by either humans or machines. So Google thought about it, and then LinkedIn thought about it, and then Microsoft thought about it, and then Amazon also thought about it. And then if you know this Panama Papers case, they also thought about knowledge graphs. And then there are some more modern applications that actually use knowledge graphs. So maybe you know this Maltigo graph. This is actually used in investigations of human rights issues. And then there is also this Traffic Analysis Hub, which is like an initiative in the UK. They also thought about knowledge graphs. So here in Chile, we also thought about knowledge graphs. And this is our initiative. It's called the Nuestra Memoria. And what we're trying to do is, again, we're trying to understand what happened in the Chilean dictatorship. So there is the issue, of course, of actually finding people. We also have people missing and disappeared here in Chile. But it seems that in our case, there is also interest in trying to understand what really happened or how this happened. So here in Chile, we had this precarity, maybe, that the dictatorship was going along with lots of social and civilian help. And then there is also, it would be nice to understand how this happened and hopefully get something for the future, right? So our knowledge graphs are going to be a little bit more general for this. But the thing is, of course, building a knowledge graph requires a lot of time, resources, money, 3 years with lots of people, and sometimes you just don't have this money. So here in Chile, it would be difficult to actually get the amount of money that we would need to actually produce some sort of a graph. We have not been able to do this, and hence the natural question, right? So can we automate this, or can we automate this to some extent? Okay, so this is what I'm going to talk about today. So it's about automatic construction of knowledge graphs, and with a special focus on historical text. Of course, we have applied this into text that has to do with the Chilean dictatorship. And as you would expect, we're using large language models for this. So this is more or less what Victor was explaining, right? So if you want to create a graph out of text inputs, and for this talk, we're going to assume that this has already been OCR'd. if you want to learn about how we're doing OCR in Chile, then there is Domingo's talk on Friday, I guess, for this. So of course you have to extract entities, then you have to do this entity linking, entity resolution, and in our case, actually, we saw that after doing this, you end up with like this huge graph, and you better do also some post-processing. And this is basically what we want to automate. So of course, you can immediately see that, well, I mean, why don't you use LLMs for extracting entities on relations? This is more or less obvious. You could try to leverage LLMs to do the entity linking. So Victor was talking about like these nice applications where you sort of distinguish some candidates and then you pass them on to the LLM. But then probably in the processing thing, you would have to incorporate experts. So this is the framework that we're working on. Of course, I don't have a lot of time, but I'm going to talk about two things. So first is a little bit discussion on tools and choices to automate graph constructions. This is on the spirit of what Jocelyn was mentioning. If you're considering building knowledge graphs, so it would be good to see what we have thought about and what we have learned from other people so that you can continue from there. And then there is also a little bit of discussion on how to evaluate them, because when you're doing things automatic, it's ever important to actually evaluate what you're doing. So, let's start with the first part, right? So we're going to extract entities and relations. And I just have a very simple example with a Wikipedia page here. Just to mention that, I mean, if you're trying to do this automatically and you're trying to extract everything from the data, which is what Victor told us not to do, there are, like, the events it could be very vague. And in terms of knowledge graphs, we also call them entities. So this is like a piece of the Wikipedia entry for KHIPUs. And then apparently this was the person that first sort of managed to solve KHIPUs, and then this other person actually understood KHIPUs a little bit more. So this is the things that we're trying to extract. So we're trying to extract persons, obviously, but also to extract events, and then linking persons to events. So, of course, the first question is, right, so are you going to do this with an ontology, or are you going to do it without an ontology? So if you're trying to do LLMs, and there are some commercial applications that already incorporate this sort of service of doing this without an ontology. So let me just say something about what happens if you try to do this without ontology. You're more or less in the blind. You cannot really do more than this. I mean, of course, you could prompt, like optimize the prompt a little bit, but I mean, you cannot do really much more than this, right? So here's the text. Please let me know what entities you see. And this is, of course, it's not very ideal. Once you have the entities, of course, then you can prompt for the relation between these entities. The way that we thought about doing this is that you would say, okay, these are the entities that you detected in this text. Now give me the relations that you detected in this text. If you try to do this, you're going to end up with a very, very, very unspecific and lousy graph, actually. This is not very recommendable. So it seems that you would need some ontology. I would expect that you would need some ontology to help this extraction process. But then, of course, if the ontology is very specific, because when you're doing things automatics, then you might actually over-confuse the LLM. So we were toying with ontologies that would look like this, so like very general things. So you would have, okay, there are individuals, there are organizations, there are locations, there are events, there are some simple things. What do you gain with this? You can get a little bit more specific prompting, even though this would imply more queries to the LLM. So now you would want to say, okay, here is a piece of text, and I want you to detect the individuals in this text. And then I want you to detect the organizations in this text, and so on, right? Now detect the places, now give me all the events, and so on. So you get a little bit more you get more precision with this, but then you could also go further, right? So you may want to say also, look, for the case of individuals, I would desire, name, gender, age. So you would like double-click the ontology to add like properties for each individual. Then you would get an even more refined prompt, and you would say, okay, get me all the individuals, And in case you see their names, give me their names. If you have the age, give me the age. If you have the gender, give me the gender, and so on. So you gain a little bit with this ontology. Then we're going to talk at the very end about some results about evaluation, and it seems that like doing these things would lead you to a better graph. Whatever this means, because this is automatic and it's a huge graph, so but slightly better. In terms of relations, we also toyed by doing like very simple relations, member of, like a person is a member of an organization, some place is located at some other place, some person knows this other person or was with other persons and so on. Again, having this ontology allows you to prompt a little bit more specifically. So the way that we do it at least is that we tell the LLM, look, you have this text, and in this text you identified all these individuals, and also you identified all these organizations. Now, please let me know which of these individuals belong to which of these organizations, right? And again, this works like way better than the alternative when you're not working with an ontology. So this is what we've seen. So in the interest of time, I don't want to talk about the NT resolution. I agree. Let me say that I agree with everything that Victor said. We have exactly the same experiences. So I don't think that we have to dwell a little bit more on this. And so we're using this approach. So these prompts that I actually show you, we're using them, and we're using them to construct like real graphs. So we have this graph from Colonia Dignidad. So Colonia Dignidad was some sort of an individual settlement in the south of Chile that collaborated with the dictatorship, and it's believed that there is lots of people disappeared there. So there are thousands of testimonies. But there is still lots to prove in the judicial system. And one thing that happened is that once this Colonia Dignidad thing was dismantled, people found like 40,000 records of the intelligence department of Colonia Dignidad. So these guys, they were Germans, and they were recording the lives of lots of people in Chile. So they have a lot of intelligence. So people that went missing, they have intelligence of them, but also people from the same government, the government previously, then the dictatorship, then the police and the military. There is lots of things. And when we apply this idea of prompting with ontologies, we end up with, and we read these 40,000 records, we already have transcripts of this, and we end up with a graph of 200,000 entities and a little bit more than 100,000 relations, so it's a huge graph. So this is powered by MillenniumDB, which is our graph database. This is work of the Millennium Institute for Foundational Research on Data, IMFD. And so this is under construction. I need to show this, yeah? How do I show this? Where? Amazing. Okay, but now I cannot see it there. So but do I have a mouse? Okay, works. If I click here. So I didn't want to show like some very specific things, but can you see this well? Yes. Okay, great. So this is a very famous like Chilean music group. They had like 10 records of this group. These crazy people in Colonia Dignidad. So they were basically annotating everything that this group did. And this is reflected in this. This is just like a very small portion in the graph. It corresponds to a record of this group, right? And what you can see, of course, is that the graph correctly detects like people that are part of the graph. So this is a node corresponding to this guy, which is actually a part of Inti Illimani. And it also properly detects some sort of events. So this is an event where actually they were prohibited to go to Argentina for a concert. And so I just wanted to show this because the events that you detect, they can be quite general. Also because in these documents they have everything, right? And then, yeah, I don't know, there are lots of events happening here. We hope that we are going to make this public soon. The interface is also on development, so we also have to fix that. Okay, perfect. I don't get amazing, yeah. So we're actually using this approach. And so in terms of evaluation, of course, you could always like manually build a graph and then try to build a scoring functions to see how similar nodes are, and then see like precision in terms of how many nodes from the knowledge graph that you build, like this gold standard, the ground truth, you manage to get. We did this for a very small graph, and the approach that I'll show you earlier, using commercial LLMs like ChatGPT or GPT 3.5, I think, it managed to get pretty much all individuals and about half of the events from the ground truth. So it's something, right? Of course, it's not perfect, and it's going to miss a lot of information. It's going to hallucinate a little bit, but it gives you something where you can work with. But then there is a problem, right? So if you can manually build a graph, then why are you doing this automatically, from the start? So basically, we have been discussing about, if we have several algorithms, right, to create the graphs automatically. So which one is better? So I will go in this last minute with this proposal that we have. We're going to submit this soon, I think. And so the idea of this metric is that basically the units of the inputs of the text are chunks. And then in the graph you have like these triples, right? So some people is related to, some node is related to some other node. This is difficult to compare. But then if you like textualize these triples, which is something very easy to do, right? So you just like read the triples in plain text, then you can actually compare, because now you have two units of the same nature, right? So it's just text. So you can, for instance, you can compare them using like the distance of their embeddings or whatever metric that you choose. So with that into extent, basically what we have is that for each chunk, we're going to be keeping the minimum distance to each triple in the graph. And the graph with the triple with minimum distance, we're going to assume that it actually represents the chunk. So how well it is represented? Well, in this case, 0.5. It's a metric, right? And then for the next chunk of text, we also look for the triple which is most similar. We annotate the distance, and then we do it over and over again, right? And then we can aggregate. So the average would more or less tell you like how well each of these chunks in the text is represented in the triples. You can do it the other way around. So for each triple, you get the textualization, and you say, okay, give me the chunk with the minimum distance. Fine, this is the distance, and then for the next triple, do it again, like give me the chunk with the minimum distance, this is distance, then you aggregate, and then you take the average, and the average would tell you pretty much like how each triple is actually represented in the text input, so that you, for instance, that you're not hallucinating or getting information which was actually not in the text. So this gives you two measures. So it's a comparison between the text and the graph, and a comparison between the graph and the text. And just to show you like some preliminary results. So what we have here is the algorithm that basically is based on the prompts using the ontology that I just showed you, using a commercial LLM, GPT-3, and then you get the same thing using GPT-4, and then you get a LangChain, which is like a framework, a proprietary framework that does the same thing that I told you, but except that you cannot modify the prompts. And then what happens is that our algorithm is actually a bit better. So here less would be better because it's less distance. So it would give you a better representation of the text. So if you compare how well the graph represents the text, then our approach would give you actually a better distance, and actually using GPT-4 is a bit better than GPT-3. But then if you compare like what part of the graph is actually containing the text, then all algorithms are pretty much similar, which is understandable because this is sort of measuring how much you hallucinate. So we're working from here. If you have any questions, I mean, I would be very happy to discuss them because this is ongoing work and it's actually quite important. Yeah. So just to say just a final remark, so the tools are ready to be deployed, but we still don't know how to use them properly. It seems that, I mean, it's not easy to convey, like, okay, use this graph for whatever you need. And I think that there is still lots of work to do actually to make this graph usable for the people that is looking for persons or is trying to understand what happened in the dictatorship and so on. Yeah. Okay, thank you.
Well, thank you very much, Juan, Ayala, Leandro, where are you? And Victor. So now we have around 10 minutes to have some kind of questions. I would like the panelists, please, to come to the front.
And I have a microphone here for the questions.
Yes. So, please, Ayala, you too. So as you have seen, many of the problems are similar, and the points where we are similar, I say we because Jocelyn and I are also working on the teams. So we are open to questions. So please.
We are not just pretty faces. We also work. No sé cómo llegar rápido. Ah, pero ya. Pero sí era buena idea pasar.
Hello. I was wondering if you found challenges related to LLMs being trained mostly on English and English culture. Like, do you think having an LLM that was as powerful as those as the big ones, but trained mostly on Spanish culture, will have made a difference? To any of them?
I think we have to train our own models. I want to train a model with our data. Hace años que quiero hacerlo. We couldn't do it until now because we don't have enough computational resources to do this. But I think this could help to improve results. Not 100%, but maybe some improvement with a model adapted to our domain and our language. I think yes. I didn't say this, but we can't process our documents with external models. So this is an obstacle. We worked with Llama because we can use it locally, but it's Llama 13 billion, I think, I don't remember, because we can't use a bigger Llama in our computers. So there are other obstacles, not only the quality of the documents.
I was just going to comment on maybe there is some kind of the LLMs not being suitable for the task anyway. So this correction of OCRs, for instance, as Victor was showing, there's some ceiling there on the performance regardless of the language. That is something, of course.
Another little thing. I shouldn't be doing this, I know, but there's another thing that could be taken into account, that this is not common spoken or common written English, Spanish. The military archives usually have a very special dialect. So maybe a general LLM doesn't have enough training data to understand and to properly extract the data from our documents. So I'm not sure. Maybe. Okay.
No, I don't think it would. I mean, maybe you would get like a little bit more precision. It's going to be so expensive that it doesn't really matter. I mean, I could think of several other things that would be much more prioritizing to have than this. Yeah.
Hi. Thank you so much for presenting this topic. For me, was very insightful. I don't know if this is turned on, right? Okay. I wanted to ask to Juan and maybe to anyone. Juan research reminds me of a technique that is vector search, that they do embeddings and then they compare also RAGs. So I wanted to ask you if you have like evaluated your solution with that techniques or differences, similarities, or how that technique could help your research.
So actually, the goal is to combine both. Actually, so if you can vector search yourself into a particular node in the graph, I think this is the best alternative. If you want to like hook this up with a like a chatbot, then you would definitely need to be doing this. So I mean, you pose a question to the chatbot, and then you would need to do like some sort of a vector search, but to the node representing this. So I mean, people are doing this right now. In terms of usability, in my experience with people that I have talked to, which is of course not the entire country of Chile, but it is easier for people to understand something like a semantic search that is powered by vector database than a graph. So we've been a little bit more successful showing this idea of semantic search than showing the idea of a graph. But they are like orthogonal things that could actually complement together.
Yeah, I get what you mean. Thank you.
I don't know if you can give us a brief overview of privacy concerns.
Who wants to talk about privacy?
Okay, this is escapes a little bit the AI. That's why I didn't mention it, but it's crazy. I mean, it's not only privacy. There's a lot of laws applicable to this. Like, is it a judicial investigation which is ongoing? Is it personal data? The stuff that I showed you is only from publicly available documents, but there's also missing regulation. Like, if I process these documents which are private, let's say, which are held by the ministry or the defense, whatever, and I get some knowledge out of it, like a triple, like this person was detained here. Am I allowed to divulge this triple? Not the document, but the triple. It gets kind of tricky. And then I'll just add one last thing. It's a nightmare because I had to show you, I mean, I don't have access to the confidential stuff, right? But why did we decide to keep it confidential even after removing the documents? Because if I come here and tell you Mr. Fernando Fernandez was torturing a guy here, there's going to be the grandson of Fernando Fernandez suing us for this. And whether he did it or not, I don't know. I mean, that's what has happened before, right? So it's really a minefield in the legal point of view. Yeah.
Yes, we have some restrictions with the data. We can use external models, as I said before, but it's not so clear, no, Lorena? Our university decided that we have to take care of privacy when we work with these documents. But a big part of the collection is publicly available in some servers. We don't have anything, no tenemos nada que ver con eso, but the documents are available. But we still working respecting what our university decided. And in our country, there is a discussion about if this information should be publicly available or not. There are some information in these documents that is very sensitive, like interrogatorios, and it's not easy to decide if it's a good idea to make it public.
Okay. Hi, thank you all for this amazing panel. I just had a little question about the technical, because I'm not familiar with OCR. But is there a way of adding some level of uncertainty to the character identification? I was thinking that because maybe for the next step when you build the graph, just to have some level of uncertainty for addresses or like names and that.
I don't know if, okay, so like Tesseract, which is like the best publicly available OCR, does give you a level of confidence. And you can create some further measures to try to see character-wise confidence. Yeah, but to take this confidence to the graph, it's a bit tricky, yeah. So what we did here, and I think this is important because at the end, what you want is to take people to justice, right? So at the end, you will have to check everything. And so I didn't mention this, and I guess it's the same everywhere, but every edge of this graph points to a document. So at the end, you go and search, and yeah. So the uncertainty is not that big of an issue because eventually it will have to be checked. Otherwise, it's not useful.
And I will introduce another edge of discussion, and it's that we are trying to extract a representation of some truth, but we don't know if that is the truth. So there is another level of complexity in this problem, is that we obtain data, we want to be capable of tracing the data back to the documents, but these documents sometimes have misinformation. So we always have to go back to the documents. That is what supports the claims that the graph represents. But those claims may be untruth. You understand what I mean? So that is another level of complexity in the problem.
Okay, first and foremost, thank you very much for your presentations. I have 3 questions, but I have been lucky enough that one of the questions about privacy has already been asked. So I have 2 left. First, considering that most of the documents you are dealing with are written in particular Spanish. I mean, police Baroque, military Baroque, and courts Baroque. And they are pretty stable, but I wonder if reinforcement learning on that particular social acts would be useful in terms of better accuracy of your systems. And the second question is more or less related. Since the particular relationships you are looking for, would a mixture of expert system be more efficient than the massive system like the llamas you are using?
Okay, I can comment super quick on the first question. I think I agree that it might be a bit too expensive to do that for the gain in accuracy, but in-context learning can help. So I'll just give an example in Mexico. I don't know if it's common. The telegrams that were sent like from the units to the headquarters by the military, they would say something like, we intercepted 3 packages. They use the word paquete to mean people they detained. Or they would say, yeah, we had I mean, they still say today, if you read the news, they say, we were ambushed by a bunch of criminals, or which actually means they went into a house and took people out, right? But this kind of stuff is more or less known. Some of this stuff is learned throughout the project, and this can be put into the context. I would argue more for this, to give like a small glossary to say, find all the people mentioned here, but take into account that package can be a person.
I can comment a little bit about the second part. So I don't think we have quite the technology yet to understand how to query meaningfully like a graph with a lot of uncertainty, that is what you would get from some sort of a mixture of experts. So of course, I mean, you are going to get more precision. It's going to be a better source of information. I'm talking about the graph part. The OCR, I think it's a bit more simple to integrate things. In the graph part, you can get it, but then you would have like this graph full of uncertainty, right? And now you have to query, and then you have to like take a triple, right, to a judge or whatever. And it's much more easy to say, look, I mean, we have this triple, than to say we have 0.8 of this triple. Because I mean, what that does mean. So I think we're still lacking a little bit of work there, but of course it's a promising approach.
Yeah. Hi. Thank you for the talk. It was amazing. And I got a question about the OCR step mainly to Uruguay, because you talk more about OCR in your research team. So the questions are the following. First, you say that you got a data set with more than 20,000 trained pairs and 2,000 tests. I don't know if that data set is public. ¿Lo digo en español?
Yes, we are trying to publish it.
Okay, it's not public.
It's not public yet because, as Ayala mentioned, the documents we are working on, they are not on the public domain.
I know.
But we get through a committee of experts trying to like kind of a censorship that we are close to get allowed to publish it, because that's always, when we present our work, it's always a claim. We want to improve, we want to help, but it would be nice to have the data so we can all try to improve the results.
Yeah.
So we are working on it, and maybe you can try to stay in contact with us. We are trying to publish it in a repo, hopefully soon.
Yeah, and the following thing that I was wanting to ask is, everyone of you that talk, I think you use the word error metric and the character error metric only. And I wanted to ask, what do you think about using other kind of metric, like more context related, like Grouch, or like more summarizing metrics? Like, for example, when you use LLMs, probably the exact word will change, but if you maintain the meaning, maybe it's useful. So what do you think about that?
Yes. For the moment, we want to keep the original texts, because this is these documents are being analyzed by social scientists and journalists, and we don't know if it's the same for them to give them text with other words. Even if they are synonyms. So at the moment we are trying to be fieles, I don't know the word, fieles to the original. Maybe we can, it's not easy to to interact with all the parts of this project. We are muchas personas from different backgrounds, and we are not always talking with each other, but maybe we can find one useful solution with large language models where some words are changed and it's okay. We have to talk with the users. It's
Thank
not
you.
easy.